You never want to hear the words black holes and the Milky Way in the same sentence, lest we want to get sucked into a vortex of either oblivion or sprawling darkness. We think of black holes as these fascinating, albeit terrifying phenomena that exist far, far away, and that scientists are years away from understanding, never mind the fact that we have a colossally large one in our very own galaxy, one that scientists have just made a groundbreaking, space-bending discovery about. Our galaxy's supermassive black hole, which is named Sagittarius A star, is a confounding anomaly. For one thing, it's proven to be impossibly elusive for telescopes to observe and explore. For another, it's been exhibiting some strange activity that has raised more than a few astronomers' eyebrows. But before we get into that, a little background information about black holes in general is necessary. What are black holes? Do they vary in size? And how much of a danger do they actually pose? Vertex, oblivion, endless darkness included. Black holes provide the universe's most severe conditions where scientists' most fundamental ideas, such as general relativity, are put to a test. A black hole is a region of space, or rather, it is a tightly packed collection of, well, stuff in space. It's packed with so much mass that its own gravitational pull is so intense that it prevents anything from escaping, even light, even a single ray of it. And because no light can escape its grasp, us curious people on Earth can't actually see black holes. Ordinary telescopes that detect X-rays, light, and electromagnetic radiation can't even directly observe black holes. But there is a way around that. We can't technically see a black hole, but telescopes can see the material around it. When matter swirls around it, its heat is cranked up to the point of radiation emissions that we can pick up on. Another way scientists can observe the activity surrounding a black hole and confirm its existence is to observe the movement of individual stars nearby. Now, black holes do come in different sizes. It's believed that the smallest black holes can be as tiny as one atom. While they may be tiny, they are still mighty, possessing a mass of a large mountain even. So far, 3 types of black holes have been identified: stellar black holes, intermediate black holes, and supermassive black holes. Stellar black holes can have masses up to 20 times more than the mass of the Sun. They occur when an exceptionally large star's center falls on itself or collapses. Intermediate black holes are the newest in terms of being discovered, as astronauts originally thought black holes only came in small and large. Intermediate black holes, or IMBHs for short, can form with a calamitous chain reaction from stars in a cluster colliding. Small or stellar black holes dot the universe, but their older, meaner sibling, supermassive black holes, overwhelm and dominate it. Supermassive black holes possess masses that are over 1 million suns added together. There is proof that every large galaxy is home to a supermassive black hole right at its center, at its core. Some scientists even believe that these supermassive black holes were created at the same time as the galaxy they are in. And yes, our own large galaxy is home to one. After scientists discovered the presence of the Milky Way's very own black hole on February 13, 1974, they gave it the name Sagittarius A. It's located at a distance of some 27,000 light-years away from Earth, and it's way bigger on the inside. The enigmatic Sagittarius A has a mass of 4 million times that of the Sun. So far, scientists have yet to crack this enigma. They have never personally viewed it, and not just because of its black holeness. We know for sure that it exists due to its dramatic effect on the surroundings, but we also don't know a lot of other things about it. Until quite recently, scientists didn't even know how much of the matter at the center of our galaxy was Sagittarius A. Then, after measuring 4 distant stars around it, their movement revealed that the mass at the Milky Way center is almost completely composed of matter from our resident black hole. So much so that it barely leaves any space for stars, interstellar dust, gas, dark matter, and other black holes. Further adding to the mystery shrouding Sagittarius A is this alarming fact. Sagittarius A is showing behavior that it's unlike anything we've ever seen before. On an hourly basis, this behemoth at the center of the galaxy flares up. Why exactly? No one knows, but we do know that these strange flares make it more than challenging to image the black holes, as well as make them a difficult target to observe that well. The fact that Sagittarius A is flashing is something astronomers have known for decades. These flashes, these flares, are believed to be 10 to 100 times brighter than normal flares from other black holes. Even after NASA's SWIFT satellite has been observing Sagittarius A every 3 days since 2006, we're none the wiser to the black hole's secrets or patterns. For example, from 2006 to 2008, the area near it was frequently flashing, but from 2008 to 2012, it was eerily quiet. After 2012, the flares returned to their riotous habits. No distinguishable pattern to be observed so far. Now, NASA's James Webb Telescope will direct its keen eye on this strange cosmic entity and work on visualizing it. The visualization part will be a collaboration with the Event Horizon Telescope, which captured the iconic and first image of a black hole back in April 2019, which is named M87. The Event Horizon Telescope first saw the black hole in galaxy Messier 87, or M87 Center, when it was examining its event horizon. Event Horizon isn't just a video game, it's a black hole's quote-unquote surface, or the boundary around its mouth past which nothing can escape, not even light. Once a particle crosses that boundary, it's forever lost. It took a team of over 200 scientists around the world to present that first photo of a black hole. This image was groundbreaking in more than just one way. It was proof that Albert Einstein's general relativity theory was right, which is that when a massive star perishes, it leaves behind a dense and small core. That was when scientists were dealing with Messier 87. Our Sagittarius A is a whole different story. Our elusive black hole is around 1,000 times smaller than M87. Among the challenges that make it all the more elusive is plasma or murky ionized gas, which exists between the black holes and our ground-based observatories. This plasma distorts images of Sagittarius A. The Event Horizon Telescope and James Webb Telescope will join hands to investigate to gain information on what exactly causes the notorious flares of Sagittarius A. This could unlock a well of knowledge for scientists. We're on the cusp of understanding black holes like never before, as well as solar flares and plasma physics. Since the Event Horizon Telescope is located on the ground, astronomers hope that the data gathered from Webb's findings will complement its data. Eventually, we'll have a clean image to interpret. According to study principal investigator Farhad Yousefzadeh, who is an astrophysicist at Northwestern University in Illinois, their purpose is to know how the universe works, because we are part of said universe. And his team holds the belief that the black holes hold unprecedented clues to some of the big questions. One of the things their team is determined to find out is if the hourly and day-to-day and long-term flaring of Sagittarius A is linked to extreme activity that astronomers observe with more distant supermassive black holes. But here's a terrifying bit. These distant, albeit young, supermassive black holes are, we wouldn't go as far as say they're devouring everything in their path, but they are inhaling dramatic quantities of material. So far, our friendly neighborhood black hole isn't consuming as much material. It's shown to be an older, more mature, evolved, and calmer black hole than others. This raises a few extra questions. What is causing Sagittarius A's unusual, unquantifiable activity? How do these flares occur exactly? Sagittarius A had already disproved the theory astronomers once had, which is that flares follow after the passing of gaseous clouds or stars by the black holes, but so far, there hasn't been any evidence for that. If there is one thing for sure, though this certainly isn't an invite to jinx current circumstances, Sagittarius A doesn't pose a direct threat to life as we know it. Contrary to popular belief, black holes don't actually go around devouring stars, suns, stars, and planets willy-nilly. Our beloved green planet will not fall into an event horizon because there is no black hole close enough for the Earth to be pulled into its gravitational pull past the point of no return. Even in the event of a black hole with the same mass as the Sun taking the place of our Sun, the Earth still wouldn't be sucked into its swirly, endless darkness. And the Sun isn't likely to turn into a black hole in, well, ever. It's simply not big enough of a star to make a black hole. What do you think of our resident black hole? If you enjoyed this video, don't forget to subscribe and click the like button. Also, don't forget to turn on notifications to get alerted every time we upload a new video. Thanks for watching.